started. Hello, everybody. So we're on that Wednesday to Tuesday schedule now. So this is starting into module 2. A couple things to go over. A couple things from module 1. There seemed to be some confusion about and stuff, so we're gonna go back over that. I also wanted to say thank you because yesterday I turned in the no-show. The list of went to turn in the list of no-shows, and for the very first time, there wasn't any. Every single person on the roster has participated in the class, so I wanted to say thank you all for showing up and participating. You know, getting off to a good start here. Hopefully that's going to continue for a while. There's Zach. Add him to the list here. Okay, so as we get started, there seemed to be a little bit of confusion on a couple of the assignments from the first week. I'll quickly mention that. Well, there's a discussion board second. We'll start with a little bit of confusion on the debugging assignments and what was expected in those. So with those debugging assignments, oh yeah, and kind of showed up the other day and was talked about briefly at the end. Is everybody able to pull up my screen bigger? Is everybody able to find that button so that you're not looking at all 20 thumbnails, so the screen's only this big? Yeah, so if you haven't found it yet, there's a button that says view, one of the disappearing buttons. I'm not a fan of disappearing buttons, but Zoom has those. Periodically buttons will come and go depending on where a mouse is. But if you're looking at all 20 thumbnails, it might be a good idea to switch to just speaker view so that you're only seeing mine and the board comes out a little bit bigger. So that week 1 assignment, the debugging assignments, those files just all have a problem in it, is what it is. So you're supposed to look through there and fix the problem. And there were a couple different confusions. People weren't quite sure what to do with it. And some people were talking about running the code. And those are just in pseudocode. The first week. And
we lost, bud. I'm already out.
What's that? Oh, I thought somebody asked a question. I guess the mic wasn't muted. So they weren't quite programming things. They're just like the steps that we need to carry out. So before we get to developing a program, one thing about software development or programming in general is programming is a thinking thing. Actually writing code, I always just refer to that as that's the tedious, busy work at the end. And it should be almost mindless by the time we get there. And we should have all our thoughts in place so that we sit down and it doesn't matter which language we work in, whether we're working in C++ or Python or Lisp or Perl. The Raptor that we use that was originally written in Perl, so might as well throw that one out there. But whatever language we work in, that the computer actually interprets or compiles and runs, by the time we get ready to do that, we should have everything ready to go. And that relates to both the debugging exercises and the discussion board from last week, which we'll talk about in a minute, but I almost deleted that discussion board before the semester started and was like, oh, I'll leave it in. So let's start with the debugging exercises. So those were written in Pseudocode. There's a couple names on the roster that seem like English might not be your first language, or it's not a very common word. So pseudo just means similar to, like code. So something similar to code. It's not quite the language we speak. It's not quite the language the computer needs. It's just that middle part in between. And one good way to think about that is a computer needs algorithms broke down into single steps that it can take. That's what we're going to talk about. That's what we're going to talk about tonight here in a few minutes. But one way to think about it is keep in mind those symbols, So we're going to keep coming back to the 1 and the 0. And really what that tells us is the machines can either do something or not do something. Right? They can do one thing or they can not do one thing. And that's the options we have when feeding instructions into a computer. So when we break down what needs to happen, it has to be broken down into those very particular set of steps, and the order matters a lot too. That's another one that's on the list of topics for tonight. So pseudocode, one way to think about that is maybe like almost like a little bulleted list of each single step that needs to happen in the order it needs to happen in, so that we can figure out what needs to happen, what needs to go into the computer. And then that final step is just putting it for the syntax of the language that's actually going to run. Excuse me. So let's take one of those examples from the debugging exercises that was due. I think the due date was a few minutes ago, but that one's open till the end of the semester. And if it's not turned in late, I'll move back late fees and stuff because there was some confusion on it. But that's one of the assignments that stays open till the end of the semester. So one of them was miles per gallon. I can't remember, I think it was number 2. It was just a quick calculation on miles per gallon. That's something we see a lot in our society, right? It makes a big difference, especially nowadays with gas over $3 a gallon. We want to know how far we can get on that $5 we can afford to put in the gas tank, and stretch it out as far as it can go. So we want to know how far we can get with on a particular amount of gasoline. And there's a couple things to look for. One thing I saw show up a couple times that if you weren't familiar with it, the word per, anytime we see that in mathematics, that means to divide. Anytime you see the word per, think division. And you can help remember that is one that goes with cars we see all the time is like miles per hour. Right? So on your car's dashboard, there's going to be a M/H for how many miles we go per hour. But just as a general rule in math, and it's going to show up a lot in programming, because one of the things that can help us put algorithms together that we'll see before too long, maybe not tonight, is just rephrasing things. Right? There's lots of ways we can say things in English. So sometimes finding similes or changing our sentences around will indicate what needs to happen when we feed instructions into a machine. And per is one of those good words to try to work in there, because that always means divide, which was actually one of the bug in there, because I think the original pseudocode had a plus instead of division. But our basic design for this program is what needs to happen. Well, to find that, we know miles per gallon is, well, right like the name says, miles per gallon. We'll take a number of miles and divide it by gallons, just writing out some thoughts. But to put this into a computer, before we divide a number of miles by a number of gallons, we need to get those from a user. So that's somewhere on this list, get miles and gallons. And we're kind of talking about this the other day, that messy stage of just jotting down thoughts and getting everything collected on the page. We might end up crossing or scribbling things all, and it turns into a mess collecting all the thoughts. But once we have our thoughts collected, then we need to transfer them to something the computer can deal with, which is a step-by-step instruction, the simplest instructions. We're going to talk about algorithms and stuff and break it down to the smallest, simplest case, and then every little thing needs spelled out in excruciating detail. This is a community college, right? So a lot of people here have kids. and if not, you've probably dealt with kids, right? And there's one of those phases around 3 or 4 years old where every instruction needs spelled out explicitly. Anybody ever dealt with that with a 3-year-old?
Yes.
Telling them to put their toys up isn't quite enough. You have to explain what put up means for every single toy and that whole process.
And it's
It's
always
like we have to do.
why.
Yeah. And that's an intelligent creature. With computers are not intelligent. So if we don't spell out every single instruction correctly like that, we don't get the why question. Things just get messed up along the way. But that's one way to think of it, because most of us have experienced that with children before. That phase where we have to spell it out so explicitly every time. So we need to turn this general thoughts of what needs to happen into pseudocode. And then that's what the downloaded file we got is the step-by-step. Well, looking through here, one of the things we do is we have to do this calculation. But before we do the calculation, we have to get the numbers. And we need 2 of them, so that's 2 separate steps. We can't get 2 numbers in one step, sort of thing. So our first step is input miles. Then second step, input gallons. And once we have both of those numbers, then we can do the math with them, right? A little bulleted list got off there somewhere. This is another one that I saw a couple times. We're going to talk about it tonight. When we do the assignment operation, in a lot of our languages, assignment only goes one way. So the assignment operator, 1 equal sign, you say miles per gallon equals some calculation. In most of our languages, the assignment operator only goes from right to left. So our calculation will go over on the right-hand side and the variable goes on the left. Some people like to think of it as just, reading the way we would read that in English, or probably think about it since we speak English, as we'd say, this variable equals something. So you can think about it that way. Always start with your variable. And then assignment, and the calculation always goes on the right-hand side. Some languages we can change that, but for the most part, in most of our languages, assignment only goes from right to left. And miles per gallon, and then we can just do this calculation. We want to take miles. I spelled it out there. And per means to divide, which was the actual problem in that, because the pseudocode that you downloaded said miles plus gallons, which doesn't necessarily give us useful information, right? If there's 5 gallons in the car, 5 gallons of gas in the car, and we drive 100 miles, we didn't get 20 miles per gallon, right? We didn't get 105 miles per gallon. We don't necessarily need to add them together for that. Oops, drop my pen.
I have a question.
Yes.
Is there any specific reason why you spell out miles and you don't gallon? Like, could you just do it in whatever order if you want to abbreviate miles and spell out gallon? Is it just a user preference?
Yes, it's just user preference.
Okay.
We could call that M and G.
Okay, so it doesn't have to be a certain thing. It can just be whatever the user prefers.
Yes.
Okay,
yes.
Thank you.
It would be much better. The more specific you can get, the better it is. I think I read up.
I have a question.
Yes.
For that one assignment where it says create an algorithm in Raptor, does it mean create the same algorithm in the video?
For the module 1 assignment, yeah, that'll work.
So
follow the steps in the video.
So create the same program in the video?
Yeah. That's just to get used to clicking the buttons and seeing where some of those buttons are.
I was just confused on what it said.
Okay, yeah, it was just to kind of getting started. And you can change it up in the video. If you want, you can do something similar to the video. Like the other question that was just asked, you could change the variable names up that are being used into something more descriptive. It would be much more descriptive to say something like miles driven and gallons used. I mostly abbreviated it on the board because writing it out by hand takes a minute. But typing's easy, right?
Yeah.
We can type really long descriptive names very, very easy. So that's probably going to happen a lot sometimes in class when I'm writing stuff on the board. That might even just go back to the M or the G just because it's quick and easy to write. But when we're coding, we want to spell that stuff out. I guess the last step is to output that. So that's what the pseudocode is, output miles per gallon. It's just this, we break our design down into the step-by-step version. And that's kind of what tonight's lecture is about. And then once we have our thoughts together, then we code it up in whatever language we want. There's lots of different languages we can code it up in. And Celeste was saying that she was having a little bit of trouble trying to code that up, just get some practice. So I asked her to share the screen so we can look at that error message and see how to fix it. Because I like to look at the error messages and fix them.
Yeah,
Find that
give me 1 second.
much more useful. Do you know where the share screen button is?
Is it the little green thing at the bottom that has the arrow?
Yes.
I don't know if this is gonna work. Hopefully it works, but I have no idea. May work.
Yep, I can see it.
Yeah, so I typed it in like just like she showed me, and it's coming up just saying that invalid syntax every single time.
Oh, okay. So it looks like you were typing the pseudocode in directly. So
Okay.
some of that is just part of the pseudocode, just sort of the process. I have a little pin thing here I can mark with. What's a good color? I'll use green. So like this start and stop, those are automatically implied in Python.
Okay.
In some languages, we do have to explicitly say start here and stop here. But and so that's getting our pseudocode, our design, our plan into the Python syntax. So you can go ahead and take out the start and stop there on line 1 and 6.
So for executing the code in Python, does it work similar to Raptor?
Yeah, they will. They're both alternative ways to run the code. And previous semesters of this course, we always use Raptor with the flowchart because a lot of people are visual learners. Humans are just a very visual-based species, right? We like to see something and be able to relate it to a picture, not just words. So using the flowchart helps us to get a visualization of how things work. Whereas Python is just, it's a very popular programming language. It's the most popular programming language in the world. So this textbook used Python. So we just went ahead and kept it around. Like, well, might as well use that. It's an easy one to work with. And now this line 1 here, that's the pseudocode that tells us what needs to happen. So to get that to Python syntax, we'll want to change it up just a little bit. So in Python, we don't have to do any sort of declaration. We don't have to say what type of thing something is. We don't have to declare it beforehand. We don't have to say we're getting ready to use a variable. We just start using it. It's one of the easy things about Python. So that line will start with the variable name. So you can go ahead and take out the input there at the beginning. And then we'll set that variable, we'll assign it something. So original price is assigned, which is 1 equal sign.
Okay.
And I'll clear those little drawings out of the way. And then this is where we would put the word input. Python, one of the keywords that's built into the language that means something, it's going to have input's a common thing, so that's built into the language ready for us to use. So type the word input and then an opening and closing parenthesis.
So do you want the closing parenthesis like around it or after it?
Oh, afterwards.
Afterward?
Yeah, and then we'll come back and put something in the parentheses. And then lowercase. And see how it
Lowercase?
pops
Oh,
up
okay.
there in the little predictive text? Whenever it shows up in that predictive text, you can hit the tab key and it'll finish typing it for you.
Okay.
Because humans are very prone to making typos, so it's best to let the computer type for us. And then inside the parentheses, and this is something I like to do whenever I write code, is I don't necessarily work top to bottom, left to right. We end up jumping around, because if we jump around and put it together in the order our mind thinks about it in, it can be a little more productive than trying to type it in the order the computer needs it in, because we don't think the same way a computer processes. So jumping around can be very, very helpful too. And then what goes in the parentheses here is the prompt, the letting the user know what we want from it. So in this case, so it's going to be a string, which we're going to talk about strings soon. It's words we actually want to show exactly on the screen. So you'll wrap it in quotation marks. So in Python, double and single quotation marks are interchangeable, but just in quotation marks, put some sort of message to the user to let them know what you want. Something like enter the price.
Enter the
Enter
price.
item price or something like that. So it'll throw those words up on the screen, and then the user will type something, and then it puts it here. So see how it's actually operating in the order that we put it in our pseudocode, but the syntax needs it in a different order, which is another thing I often like to point out is that's kind of like English, right? Python's based off English statements. So we read that left to right, but when the computer runs it, it does this part first. So the computer actually operates right to left. So we have to adjust for the orders and things like that because the computers don't process in the same way we do things.
Yeah.
So that looks like it'll run up to line 4 without an error. If you hit run, it should get a little bit further. So it asks for a price, and you want to start with a simple case that you can easily do the math, right? Like $1 should be 10 cents off, right?
Okay.
So it ran further.
Yeah.
What'd that say? Type error, can't multiply. Oh, when you type that in, you put a space and then type the number. And it brought the space in as part of the number. So it had space 1.00.
Oh, okay.
Which made it think like it's a letter. So it's often good to end your prompt with a space. But you can just type a 1 right there instead of if you just hit 1 and hit enter, it should run it. Wait, why didn't it like that? Can't multiply sequence. Why is that a sequence?
I don't know. I have no idea.
Does she have to say like change the original value of original price to an integer? Like does it have to be orig price equals int input enter item price?
Because it's a percent, it's need to be a float.
That might work, but It thinks it's a list.
Or
For some
probably
reason.
can be because after the multiplying sign, she had a space.
Oh, was there another space there in the? Did you have a space afterwards?
Like right here.
No, it shouldn't be. That should be fine.
Hmm.
Enter item price. With price discount equals order.
Does it have to be in parentheses?
Which part?
Wait, were we supposed to do the debugging program on Python?
Oh, no, she was just asking about this, so I thought we'd go over it, because that is good practice to try to run those, and it seemed like a good place to see the difference.
Like, does the 0.1 need to be in parentheses to differentiate that you're multiplying it by that?
Yes, this problem is actually going to turn into a big issue. It doesn't like.
Try to put float around the input.
Yeah, you have to take original price into a floating point number. Somehow the settings got changed, so it needs strictly typed original price times type. So if you go up to line 1, so the problem, what's going on is when we get that input, it's coming from the keyboard, right? And the keyboard is, well, the main part of it's our alphabet. So even when we type a number, it's still doing that. It's using the symbol from the number. It's using the symbol 1, not the number 1. Does that make sense? It's actually in our code. We'll talk about it next week. It's in module 3 where we're learning how the binaries are mapped. So instead, when you type in 1, it's using 49 instead of 1 because that's the ASCII code, the Unicode value for the symbol 1 instead of number. So if you take input, that whole input thing, and wrap in parentheses, so put more parentheses all the way around this.
Okay.
And then at the beginning, type the word float. So like right over here. So FLOAT. All right, now it's further. If you hit run, see if it'll do the math out. If you just type 1 and hit enter. Okay, so it ran a little bit further. It didn't output it though, right? On line 4, of our pseudocode. It's just saying what needs to happen. So our syntax for Python is to put the word print, which I'm writing with the mouse, so it's really hard. It's really, really hard to write with the mouse. Yeah, the question came up about the on-computer whiteboards, and all I have is the touchpad on my laptop. So if you go ahead and take all that out, write print, and then in parentheses, put the final price. That's the word that means output. And notice how it's predicting it. You just hit tab and it'll fill that in. So now if you run it, it should work. Enter a price of $1. It would cost us 90 cents. Those steps make sense. That kind of help.
Yeah, that helps a lot to be able to actually have something that works. I am a visual and an auditory learner, so I can listen to things and kind of understand it, but then I also need a full like working example to be able to actually do it. So having this helps so much.
Okay, yes, we're going to see more and more and more of those. So
Okay.
that's what Pseudocode does. Notice how this is a lot more like in English. Because
Yeah.
we could then take that and do that in any of our programming languages. because after that, it's just the syntax. Or we could put that in Raptor where we drag those symbols around. We have a couple of the input symbols we saw the other day, the parallelograms. Then the miles per gallon, that's an assignment, which we're dealing with the variables. So we'd use one of the rectangles. And then another parallelogram for the output at the bottom. You see how it's kind of related no matter how we type it up.
Yeah.
At some point this semester, I'm going to look at this thing called Blockly that has been used to make other programs. It's another symbolic one. It is really, really, really nice to do with one finger on a thumb. Do with one finger on a phone, like drag your thumb around on a phone. And I like to do things on my phone, so I thought I'd show that at some point this semester. So we'll see different ways that we can apply things. Mostly we're working the algorithms in this course. So we'll deal with pseudocode, and then we can take that pseudocode to a flowchart interpreter or the Python programming language or any of our other languages. So hopefully that kind of makes sense.
Do you want me
That
to stop
transition.
screen sharing?
Yeah.
Okay.
That's right. I started writing on the board. I drew the pictures from Raptor over here, but we saw those the other day. Parallelogram for input and output, and then a square to do that math in. So it would work exactly the same. Y'all want me to put that together in Raptor real quick? Does anybody want to see that and see how it's still the same application? I see a couple head nods. So
Have at it.
Please.
Absolutely.
so let me share my screen. Yeah, because part of the thing with with school and stretching this out over a couple years is that we have time to slow down and look at stuff, right? There are the 3-week coding boot camps where there's not time to slow down and do that. Right? You got to get it all shoved into 3 weeks, and then you can analyze it later. We have time to analyze it along the way and see what they have in common. That's what we want to do. We want to look at what they have in common. So that's our logic. That's our plan. So we need to implement that here in Raptor. And this is probably a great time to look at this button afterwards too. Notice there's a button that says generate. So that button, the label on that button might indicate it does something very, very useful for us. So looking at that pseudocode on the board, which is probably written a lot nicer. The pseudocode you downloaded was a lot nicer, except for that plus sign where we should have been dividing. The whole debugging exercise, debugging point. Does anybody know the story of debugging? I just remembered it's not in this textbook. We should talk about that. So Grace Hopper, the name that is definitely worth knowing, right? She was one of the early ones that developed it in America. She eventually became Admiral Grace Hopper, but she was one of the ones working on the original machines when secret project in World War II. And one day things weren't working right. They didn't know what was going wrong. This might have been after the war. I think this was actually on a Mark III machine after the war, but there were still only 5 or 6 people in the world that knew how to put these together. And nothing was working right. So finally, Grace Hopper went in and just started taking the machine apart. It's like, something's got to be wrong with the device because our software, it should all be working. So she started taking the machine apart and eventually found a moth. There was a moth flew in the machine and it actually shorted out the circuit and it got stuck in there and caused a short in the electrical circuitry. And this was a military project, so obviously she had to write a report on that. So in the report she wrote, I had to debug the machine. She took it apart, pulled the moth out, and put the machine back together. And then that word is just stuck around. That's the word that's stuck around, is whenever there's a problem, we call it a bug. It's like a moth flew in the machine and shorted out the circuitry. So yeah, she's one of the ones that pretty much invented that, Grace Hopper. A name to know for computer stuff. Right? We always know the actors and celebrities. Every once in a while, it's good to know the geniuses that brought humanity to the point we are now. Especially when it was a woman doing these things in the 1940s, because the 1940s weren't the most equal rights sort of decade. Not exactly known for equal rights in the 40s and 50s, and she did make it all the way to the rank of admiral at that time. Okay, but back to this. So that's what debugging is, fixing problems. There's a problem, once it's fixed in the pseudocode, we can apply it. Well, we just saw it in Python, and we'll do the same thing. Yes.
How do you submit a project on Python?
The Python ones that are in the textbook,
Yeah,
there's a submit button right there on the assignment.
Is it on the web on
It's in the book.
in the book?
They're in the book, and then we'll do that. We'll look at that in a little while, Zach.
I'm just curious because I don't see the submit button.
It is kind of hidden, so stick around at the end of the class. We'll look at that.
Okay.
It is kind of hidden. It took me a minute to find it too. So yeah, back to this. We have our pseudocode. We have our plan. We know exactly what the computer needs now. So first thing we need to do is get an input. Oh, and Raptor makes us save if it hasn't been done in so long. Another thing about Raptor, this was specifically developed to teach new people to program. Back in the 90s, the Air Force had people develop this to teach people to program. So it's there's a lot of simplifications in Raptor that make it really nice to start off with and get that visual aspect. We can picture things flowing through this flowchart. But once it's saved, you double click on it and enter some sort of prompt, just like what Celeste had there. Enter item price, which in this case is, a prompt we're asking the user to type a number. But logically, if we're working with different devices, do you think there'd be any difference between that and scanning the barcode? Once it's set up in the device, it's about the same thing, right? That's just how we get the numbers. So a different way to, instead of a keyboard, there's some lasers that reflect off the packaging, and we don't have, instead of typing the number 1, the user just wipes that barcode right past the laser, and it reflects back on the sensor and knows what the price of the item is. But essentially after that, the logic would be the same to program the cash registry. So again, with that point of, it's good to look for similarities and kind of think about that stuff. And then where are we going to put that? What was the name? Or is that what you used? Original price, kind of abbreviated original. Okay. I saw head nods on the pictures. So notice it's the same as what we did in Python, that first line, just a different syntax. We had to prompt the user differently and spell out our variable name differently, but we use the same variable, the same prompt, the same logic from the pseudocode. And then to do math, that's an assignment. So we'll bring in an assignment box, and we want to set discount equal to that original price. And I just started typing, and notice how it showed up there at the bottom in red in that box. In some places that it works, like the predictive text on that IDE just a moment ago, where you hit tab and it'll finish it out. On some places it doesn't in Raptor, but when we're doing assignments, it does work. So original price times 0.1 gives us a 10% discount. Or a couple people went in and approved that and did it all in one line. I did see that in a couple of things. Good job on that. Those of you who realized that we can also just do final price equals original price times 0.9, because that gives us the same thing, right? The other 90%. But I guess the best way to look at that right now is that's a good example of there's more than one way to do it. There's lots of ways to get the same results. So as long as the final result is correct, that's what matters. As long as the program doesn't crash and fall apart on its own and the final result is correct, then that's what really matters. And then finally, we have this final price variable that we're going to set to the original price minus the discount. So same logic as what just applied in Python, right? And then once we have it, we can output it. I'll just output final price. Kind of like a cash register. We just see that last little bit. But the logic is the same. Our algorithm is the same. Once we have the steps spelled out in that nice little bulleted list of the pseudocode explaining what needs to happen, we were able to take that to these two different things, the Python programming language or this thing. And when I run it, it should step through there, enter the price. You always want to check good values, bad values, and nonsense values to see what you get. Right? So like enter 1, that's an easy one to calculate. It should be 90 cents. It's not formatted as money, but 0.9, 90 cents. And we won't see how to fix stuff like this for long, but part of the debugging process is checking bad input too. What happens if we ask for a price and the user gives us yellow? That'll be a problem at this point, right? Yellow times 0.1 doesn't mean anything. We'll see how to fix that here in a couple weeks. But check good input and bad input, complete nonsense. What if we say the price is negative? Say the price is -5. The final price is $4.50. It still took 10% off. But that negative $4.50 is a strange thing to see in a price. So you always want to run different checks and look for what happens under different values. So we saw it in two places now. Right? So let's type it up in Python. I should do it together here in Raptor. Then we have this generate button. Something in the chat room. Let me check that. Oh yeah. So in a real cash register, the -450 would be a refund, and we probably don't want that to happen every single time. We don't want the customer themselves to decide when they get a refund. We want the store to decide, the manager to like come over with a key or scan something he has to scan in order to give the discount. So there's several languages here: the programming language Ada, C#, C++, Java, standalone executable, or VBA. So maybe we want to see what this looks like in C++. I'll click that option. Perhaps. And C++, like Python, is a text file, so I just need to open it as a text thing. I don't see the one I was actually looking for, so I'll open. I have several text editors here. I should just use Notepad. Probably gonna take a minute for Atom to open. Atom is a really nice text editor when you need one. ATOM. This was put together by GitHub, which you all will hear about at some point. That's a repository where programmers share code, so we don't all have to start from scratch every time. Like the open source idea. Okay, so here's what that looks like in C++. So we had to include a couple libraries. C++ is a very basic language. The things aren't there already. But we'll need these libraries to make that work. The namespace is related to the libraries. And we create a string, which it called Raptor prompt variable. It gave this huge, long, messy name for a string, but we didn't type it. As long as the computer typed that variable name correctly when it reuses, that'll be fine. Then we have a floating point number called original price. floating point number called final price and a floating point number called discount. So then we assign that prompt into that variable. Then C out, that's the console out. We're gonna, this is bit shifting. So we're gonna have a bunch of ones and zeros. That's how all our data is. That's what we're gonna start talking about Monday, then Wednesday, the following Monday, and probably the Wednesday after that. We're gonna talk about how to interpret those ones and zeros. So we'll see that, but our data is stored as a bunch of bits. So the console out, we're gonna shift out the bits stored in that variable. And then we're gonna shift out a line break, a line feed, the end of line character. Then we're gonna shift in, so console in, the user's gonna type, next time the user types something, we're gonna shift those bits in and stick them in this original price variable. And once we have that, then we're gonna take discount and set that to 10% of the original price. And then we'll take the original price, subtract off that discount, put it in the final price. And then our console out will shift the bits stored in final price out to the console. So a little bit messy compared to looking at it in Python, right? You'll probably have a very strong opinion about how much nicer it looks to code stuff in Python than C++.
Okay, I have another question. I'm sorry.
Yeah.
For future reference, is there going to be a specific language that you would prefer us to code in? Like, you know, you said that there was C++, there's Java, and like, is there a specific one that we should get comfortable with?
So since the textbook includes Python, you can use Python if you would like, or you can use the flowchart. Because like, I was going over all that just to show you that after we draw the flowchart, we can just write the code for that.
Okay.
You just click on, I'll click one more on Java. So it said it generated it. That one went directly somewhere. If I go to the file where that's stored, yeah, I was just showing you that this can do this. So we don't have to type all that code, right? All those weird symbols and the angle brackets for the shifting bits back and forth, the curly braces, the semicolons, that's an easy place for a typo to happen, right? That's why the things where we drag our mouse around and let the computer write the code are really nice. Another thing with that first one we looked at was C++, which has been a very popular language for a while. And every language that is, if we look at the list of most popular programming languages, every language above C++ was created with C++. And there's really good reasons why computer experts took that language and used it to make a new language. It can be a little difficult to work with. Java might be a little bit better. If I open this one real quick, just to kind of see that we do the same thing in all our programming languages. So just learning that visual representation, like the flow chart, we can still kind of get the same thing happening over in the actual languages. It works the same way. That's how we give instructions to the machine. So for this class, anything we do, it will be perfectly okay to just leave it in as a flow chart or as a Python script. So our book has the Python script, and whichever one you prefer. Both is really nice. Whatever helps you learn best, whatever makes the most sense to you.
I have a question too.
Yeah.
Sorry, I didn't mean to cut you off.
Oh, please do, because that's the only thing that works in Zoom calls. You just have to yell when you have a question.
So to go off of like what she's saying, so you said flowchart and Python are the best, but I'm sure with us taking like classes in the IT program, this isn't going to be the last time we see this stuff. So is there one that's best to stick to, or like, are we going to see a variety later on? Or...
Are you going into software development?
Informatics.
Informatics. So if you're doing a lot of programming, which informatics, you'll see several different things. They are all very similar. Because
Okay.
like that pseudocode we wrote,
Uh-huh.
that same thing applied to all those different languages. So really you just want to learn one.
Okay.
And Python, everything about Python was designed to make it easier. So easy on the programmer. So that's a
Okay,
good one
cool.
to focus on. And then there's slight differences in syntax, but you can quickly pick those up and they're all very, very related. They're all kind of done
Okay.
in the same way.
All right. Awesome. Thank
So,
you.
Yeah, you just want to pick one, and then throughout the semester, I was planning on looking at at least one more visual one and one more type language, probably in week 6 or 7. Just do a quick pass of all the stuff we've seen in Python and Raptor. And well, there's one that Google developed that is really, really nice to do with one, like your thumb on a phone. And I like to do things with just my thumb on the phone as much as I can. So I want to look at that one, and then yeah, we'll see what it is. And I figure by week 6 or 7, I'll have a different, better idea of where different people are heading in their IT careers, because all the programs have to take this course. So then I'll pick a language that'll be useful for the most people. I think something that'll be very useful. So we'll see it in different places, but you just want to pick one, and they're all very related. So does that help clear up what's the point of what's going on with those debugging assignments and kind of what we're looking for in those?
Yeah, I made it a lot clearer.
Okay, yeah, some of them might be in that, but in general, you can also, it's fine to leave it in the pseudocode. Or there was one that was a picture, right? In that picture, you can just open it and edit it. Do I have the picture on here, or would I have to go download it? Oh, I do not have that picture. So I'm just going to take a random screenshot real quick. So Windows Shift S just to have a picture. Earlier this afternoon, I was sitting around bored and I cleaned up my computer. I did have stuff before then. I'm just going to grab a section of the screen. So when it's a picture one, like the flowchart one there, you can just open that picture. Oh, I thought I took a screenshot. Did I not take a screenshot? Let me try that again. It didn't pop up. Windows Shift S. Oh,
I have mine pulled up if you want me to share it.
Oh, that'll work. Yeah, if you can share your screen real quick.
Sure.
Yeah, I downloaded that this morning to do that, and then forgot about that when I was sitting around bored. It's like, oh yeah, I can clean up the computer a little, do the little bit of maintenance. Yeah, so when you have the picture, you can just open it right like this one. Oh yeah, and then right
Did it
there in
go?
Photos, you have the edit and create button. If you just hit that, you can, this button right here, you can draw some stuff on there. And so in this case, get tablespoons. Tablespoons is equal to tablespoons divided by 3 output teaspoons. So that's kind of a problem, right? Because teaspoons was never used before the output. And if you're not familiar with the sizes, you can just check Google. I did have to check it on that particular math problem because I couldn't remember which one was bigger. Tablespoons are the bigger ones. So tablespoons divided by 3 gives us teaspoons. So we have tablespoons, then you just cross that off and write teaspoons or something right in the picture. It doesn't have to be neat and organized, right? This is a planning phase. Does that make sense to everybody? Open up the picture and draw right on the picture. We'll be fine for those.
So we just
And,
like that.
yep.
Okay.
Yeah. Or just whatever it would take to correct the thing. Yeah. Once
Okay.
you grab your pen stuff, just cross stuff off, write what it should be there, or make some notes on it. And it doesn't have to be super neat because this is part of the planning phase. Right? It's not the final code that we're feeding into the computer. So that will be enough for that one. For those, because yeah, that is new for the Ivy Learn shell this semester. I do try to stick with the statewide shells just to be consistent with all the Ivy techs. I did change it up some and I drift off some, but I try to be somewhat consistent with that, which kind of leads us into that discussion board. That first one, I almost deleted that discussion board. Typically, I don't bring up the different strategies for how to carry out a plan at this level, right? This is introduction to logic. This is where we learn to make a plan. And it seemed really, really strange that the very first assignment, before we get to talking about anything about making algorithms and stuff and putting together code, is a description of popular methods, or want you to go through a list of some of the methods for how to actually implement our plans and what those go together. So I did see a few questions about the discussion board and stuff. There were some great answers on there. I considered deleting it, but I didn't because, well, it's in the statewide shell now. So other teachers, when you get in their class, they might expect that you have heard words like waterfall and DevOps and have heard those words at least before, right? I saw some great answers on there. It looked like everybody was making sense of it. Yeah, I really considered deleting that. So if you wrote anything, I'm pretty much just going to put full points on everybody's thing on that one. The discussion boards are very loose. It's a discussion for you all. It's not a formal essay thing. But since those were included, this is like the waterfall method. Right? We have step 1, step 2, step 3, step 4, and then you saw when we did those examples, then we test it. If things are going wrong with the test, we come back up, make any adjustments, test it again. So it's like a waterfall, right? The water just starts at the top and flows down. And if something goes wrong, we have to go back up here, make all the adjustments all the way through, and then again it starts at the top and goes down. That's the waterfall method. It flowed down. It seemed like everybody was understanding that pretty well. Then agile methodology is very similar to this. One thing that's often misunderstood with agile development versus the waterfall method is people want to confuse it with making it up as you go along. But it's not really that, because making it up as you go along is kind of a bad idea, right? Especially with computer programming, things are interrelated, they're connected. So a change down here, right? If we change how we spelled that variable, we have to go back up here and make changes that lead into it. So things are interconnected, which means making it up as you go along is a bad idea. So a good way to think of the agile methodology is you have a plan with those steps, but there's a big maybe involved. Maybe do this, but as we start carrying out these steps, we might have a better idea. We might come up with a better way to do this. I guess a couple people in that example we were walking through there with the original price and the 10% discount, which is different than the one wrote on the board. I kept pointing back at that one. Sorry about that. But the original price and 10% discount, some people went ahead and combined that and just did the new price is 90% of the old price. So that's like agile methodology. We have that list of steps, get the original price, calculate the discount, subtract the discount. once we start to implement it, we realize there's a better step there. So it's adaptive. It adapts to new needs and changes. One word that you definitely have to watch out for, since we're talking about things, since that stuff was brought in, you definitely want to watch out for something called scope creep. And it's much, much worse in agile methodology because we're adapting to changes. Or that discussion board also mentioned rapid application development, where it's a respond rapidly to customers' demands. So maybe somebody asks us for this program, right? The one here on the board is that miles per gallon thing. So I'll refer to that. Somebody asks us for a miles per gallon thing, and we start putting it together. We get about halfway through it, and then the customer that asked for it was like, oh, wait, can you include gas prices in that somewhere so that it doesn't just give the miles per gallon, it gives the cost to take a certain trip. That's just a small feature. We can add that. That doesn't seem like much, right? So we start to add that in. And then before we get done, the customer, before we get finished coding it, the customer has another idea. They're like, oh, is there a way you can work in like shopping around for different gas prices? Like some way to tell what the best price is? And there's another feature that they went in their piece of software. And that's scope creep. Because as the more and more demands come up, we can't ever get the thing finished because the customer keeps wanting more and more things added in. The waterfall methodology is a nice way to avoid that, because then we can say things, then we can have a great phrase, which is wherever you're heading in IT, a very useful phrase to remember is, that'll be a great thing for version 2. That'll be a great thing for the next upgrade. But we should get the original one done, and then we'll put that in the upgrade, because customers will keep thinking of more and more and more ideas, and projects will just grow and grow and grow and grow. That's kind of happened to a lot of people building software for customers. It just keeps growing and growing and growing, and suddenly there's like not even an end in sight. It's just like this software just keeps growing and gets bigger, harder to work with, more complex, and plans need redesigned. Because even the adaptive ones, we don't jump in without a plan. There's this big maybe involved. Maybe our plan is a maybe situation, not a definite situation. So it's ready to change because we know that's going to happen. We know the customer is going to think of new ideas they want and things like that. We just have to be careful to limit it. You don't want that to run out, just run away uncontrolled. So the term for it is scope creep. The scope of the project slowly creeps bigger and bigger and bigger and bigger every time somebody gets a new idea. So one of the best things to deal with that in any situation is just remember that that scope creep is good for version 2 or version 3. It's good for the next upgrade. You don't necessarily need to delay things or increase costs. That's another good one for customers to limit scope creep, is if they start making a lot of requests. Just say something like, okay, yeah, I'll run the numbers and see how much that's going to increase the cost. And that usually cuts out the request very, very quickly. Once they realize that more features means more cost. But that's what that discussion board was about. I almost deleted it because in the past, like that would be mentioned some. We didn't really get in, I never really talked about the names of those things at this level. The only time I ever really remember talking about the names, I think, is in the 273 class, if that's the right number. The analysis and projects class that software developers take right before they graduate. Is it okay if I erase all this? And we can get to the next stuff. But it looked like there were some really good answers on that. It all made sense, and just some vocabulary terms about ways to deal with it. So mostly what we're going to do with this class is sort of a combination of the waterfall. We're going to treat it like the waterfall thing. We make a plan and put it together, but we're learning. So there's a big maybe that plan's going to change, which is more like agile stuff. So that's kind of what we're doing in this class. Rapid application development is all about the change. We're not really going to do a whole lot of that in this class per se, because we're trying to learn how to get this stuff together, so we don't need to be changing it halfway through the learning process. So it's gonna be a lot more like waterfall and agile. And then DevOps is very, very detailed versions of that. I often associate DevOps with micromanagement. You can think of it that way. So you have the plans and what's gonna happen, and then the boss for the project micromanaging every little aspect of it, keeping it all on track and kind of carrying things to the extreme. Okay, that took a little bit longer than I was thinking about for talking about those. Does anybody have any questions about those debugging assignments or discussion boards? What was going on with that? It seemed like there was some confusion, but it's mostly just remember those terms in case they show up later in other classes. Waterfall method is the standard. That's what our book talks about, where we put together a plan that starts at the beginning, we step through it, and when we test it, if something's wrong, we go back and adjust our whole plan. And agile methodology is a step further, where we put together a plan, as we start implementing that plan, we make changes to the plan, and when things don't work, we don't have to redo the entire plan, we can just redo sections of the plan. And those are the two big ones that we'll actually kind of use in this class. And for discussion boards in general, they're very informal things. I'll pretty much always give the points on it if you go in there and write the minimum amount, right? Usually a paragraph or two, and then discuss with your class, discuss stuff with a couple classmates. And I'm pretty lenient on grading. I know y'all haven't seen a lot of grades yet. Well, some of y'all have had me in class before. There are times where I'll put all the points on there and just throw in the comments the things that went wrong, the stuff that other teachers would have taken points off for. And sometimes I do that a bit too much and end up giving out extra credit, because the people that do really, really exceptional jobs, it seems unfair compared to the ones that I still gave all the points on. But I'm very lenient with grading is the general point. So and discussion boards are very informal. But that took a little bit longer than I'd originally thought it was going to. Seems like it's probably a good time for a break, right? I'm starting to get a little bit thirsty. So 10 minutes sound good?
Sounds good.
All right, so we'll get back to it at 7:20 and start talking about problem solving, which is what this class is really about. Problem solving and algorithms. So I will see you all in a few minutes, and I'm gonna go get a cup of coffee.
I have a question.
Yeah.
Where's the submit